Today, I want to give a short primer on decorators in Python. It's actually quite simple, but the name decorator sounds a little ambitious, so it scares some people a little. If you are one of them, hopefully after this primer you will feel more comfortable about it. A decorator is what can be applied to an object, in this example, a function, and modify the behaviors of that function. Once you define a decorator as above, you can use the syntax at the name of the decorator and apply it to or decorate some function. This looks mysterious right now, but it's really equivalent to calling the decorator with this function as the argument and renaming it to itself. That's almost all you need to know about Python decorators. By using this syntax at, it greatly simplifies the code and makes it nicer too. It's super powerful, and almost all Python developers use it one way or the other. Let's look at a simple example. Here we define a function. We call it myDecorator, which takes the function as the argument. Inside the function, we define another function called addOneMore, which will call the function, the argument, but add one more to it. And this decorator will return this internal function. Now we can compare a function and its decorated version with this decorator we just defined. We define a normal function to add 1 to the argument n, but below we define another function with the same functionality, but we decorate it with myDecorator. In order to show that it's really equivalent to calling the decorator with this function as the argument and renaming it to itself, we define another function, again with the same functionality, and call the decorator directly on it, and rename it to itself. Let's first see what those functions do. The normal function, the undecorated one, just adds 1 to the argument. Here, it adds 1 to 5 and returns 6. The decorated version, add1 decorated, will add 1 more and return 7. While the one we applied decorated directly to, add1 functional, does the same and returns 7 as well. It will help if we see the description of each of those functions. The undecorated one is the function itself, while the decorated one is actually the internal function of myDecorator underscore addOneMore. And the addOne functional is also the internal function underscore addOneMore, equivalent to addOne decorated, as we mentioned earlier. Because the flexibility and the special design of the Python language, a decorator doesn't need to be a function. It can be a class as well. Here we define a class called myDecorator, and we override the internal call function by calling the function it will decorate and add 10 to the returned value. We can now use it to decorate the following function, which is to sum up all the elements in two lists, x and y, but the decorator will add 10 to the sum. If we output the description of this function now, we see it's actually an instance of the myDecorator class. If you call it with these two lists as the arguments, 1, 2, and 3, 4, without decoration, it should return 10. But after decoration, it adds 10 to the sum, so it returns 20. So that's it. Python decorators are convenient ways, a kind of syntax sugar, to modify a function's behaviors. In fact, you can apply it to a class as well. Hopefully you have got a first taste of how powerful they can be after this short primer. Okay, hope this is helpful. Thanks for watching, and hope to see you again next time.